the angle between a line and a plane. The angle between a line and a plane is the acute angle B that's formed if we were to view everything side on. So we got this situation here, this arbitrary plane in three-dimensional space, and if we were to rotate everything so that we could look at it from side on, so this line here would be this line here, so we're staring at it from that direction, then this angle here, B, is the angle between the line and the plane. So we have a nice little exercise here to show that for the line r of t is equal to a plus t times b, so b is the direction vector of the line, and the plane with normal vector n, the angle between the line and the plane is angle b, which is equal to 90 degrees minus cosine inverse of n dot b divided by the length of n times the length of b. No problem. So first of all, let's suppose that b is in this direction. Then clearly we have that n dotted with b divided by the length of n times the length of b put into the cosine inverse function. That's going to give us a by the definition of the dot product there. And so, well, clearly b is equal to 90 minus a. So there's not much to do here. On the other hand, let's suppose that we have our direction vector b going this way. So actually, in that situation, we would have cosine inverse of n dotted with b divided by the length of n times the length of b. That would be equal to this angle here. It would be equal to 90 plus theta. And observe also that theta is equal to b. And so if we put this into our formula, we apparently get b is equal to 90 degrees minus cosine, well, minus this thing, which we figured out is 90 plus b. And so we get that b is equal to negative b. So, big mistake here. And so we see that this formula actually only works if this thing here is, I guess it has to be less than 90 degrees. But, well, in any case, we can make the formula work if we take the absolute value of it. And then things will be fine. But yeah, be a little bit careful with that. So this brings us to exercise 6.9. Find the angle between the plane pi with this equation here and the line L with this equation here, correct to one decimal place. I'm going to write that in a way that I prefer. So x, y, z dotted with 2, negative 6, 1 is equal to 15. Or, of course, another way to write that is 2x minus 6y plus z equals 15. So the normal vector of this plane is 2, negative 6, 1, or any multiple of that. So that's the plane pi. And then as for the line L, we have 3, 9, and 0. There's no k component of the initial vector, plus t times 1, negative 2, 4. So the direction vector of our line is 1, negative 2, 4. Okay, and we're looking for the angle between L and pi. Let's draw a little sketch. This is our plane pi, and then we have our line L. And then we have our normal vector n. So the normal vector has coordinates 2, -6, 1. And we can say the direction vector of our line looks like this: 1, -2, 4. For now, it doesn't really matter. And let's go ahead and find theta, the angle between them. So theta is equal, by the way, let's give this vector a name, B. So theta is equal to cosine inverse of n dotted with B divided by the length of n times the length of B. So that's equal to cosine inverse, so 2 times 1 is 2, 2 plus 12 is 14, plus 4, so that will be 16, divided by the square root of 2 squared is 4, plus 36 is 40, 41, times the square root of, so this is the length of B we're calculating now, so 1 squared plus 2 squared plus 4 squared, 4 squared is 16, plus 2 squared makes 20, so 21. And we can get our answer in degrees here if you want, since we're not doing any calculus with them or anything. So we're just looking for the angle value. So you can use degrees here, and it's common to use it for these kinds of questions. So yeah, our theta value is 56.956 degrees. And if we had something that was bigger than 90 degrees, that would have meant that we were taking a b vector in this direction, so we could simply times that b vector by -1 to bring it to here. Okay, anyway, that's not actually the angle between the line and the plane that we're looking for, though. Imagine that the sun is up here above this, and the sun is casting a shadow on top of this green line vector. So then let's suppose the shadow looks like this. Well, like this, I guess. So that's the angle we're looking for here on the other side of that. So clearly together theta and this angle, which we can call alpha, is going to make 90 degrees. And we just found theta, so therefore alpha is equal to 90 degrees minus theta, which is equal to 33.0 degrees to 3 significant figures. Okay, so that's how to find the angle between a line and a plane. Now it says here